Hi, everybody. Since we started a little bit late, I'm going to keep this nice and short, unlike our guest, Greg, who is quite tall. And yeah, this actually it rose out of a discussion we were having between some kernel folks that I know and Brian Swetland, right over here, about sort of the nature of embedded system. What's that? Well, no, I mean like from outside the company, inside the company. Like, I'm speaking here. All right. Go ahead. Anyway, and so, at the end of it, I said, hey, why don't you come out and speak? It'd be fun for us and fun for you and stuff. So here we are. Greg.
Thanks. This working? All right. I'm Greg Kroah Hartman. I'm a Linux kernel developer. I'm a subsystem maintainer of the kernel for USB, driver core. I used to do PCI, I2C, a lot of weird things. I'm one half of the stable kernel maintainer group, which I'll talk about later. So here we're going to talk about the kernel, the process, who's doing it, how it's being done, why you should care, and why Google should care, and things like that. Please heckle, ask questions in the middle. I like it. Make fun of me. I'm going to make fun of you, so be even. So first thing, this is the most important thing. Don't get anything. Realize this. This is what the Linux kernel did for the past year and a half, from the 2.6.20 to 2.6.25 kernel. This is what was changed per day in the kernel. This is a stable kernel. This is a stable development process. This is freaking insane. It is the fastest moving software project known to anybody. Largest project of its kind known to anybody. But it's also created a result that's never been done before. We have an operating system that supports more devices than any other operating system ever has. We support more processors than any other operating system ever has in the history of computing. And we're doing it in an open manner, in a very chaotic manner, moving at a rate that fast, shipping something that's stable, that everybody, including yourself, uses every day. We broke all the software development rules, and we're continuing to break it. If that doesn't make you guys scared, it should. The biggest thing that should make you guys scared is if you keep your code outside the kernel, that's going to pass you by. Do you think you can keep up with that kind of rate of change? Figure out what's going on with that rate of change? If you get your code into the kernel, that rate of change will happen to you automatically. If you don't, it'll blow you by. So get your code in the kernel. It's the main thing I want to talk about. So that's it. That's crazy. And also, this is the first question people ask, like, oh, that's just drivers, right? Drivers are changing that fast. No, it's the whole kernel. I look at it. I broke it down by the proportion of the code size of the kernel. The kernel's about 9 million lines of code. The core of the kernel is 5%. Drivers is a little over 50%, 55%. If you look at the rate of change in each individual portion, it's exactly proportional to the amount of code that's in the kernel for that section. So the core of the kernel is changing at 5% of that rate. The drivers section is changing at 55% of that rate. The architecture-specific spot's going at, what is it? I don't know, it's going at 30% of that rate. So it's uniform, it's flat across the whole thing. So don't think that just the drivers are changing, it's the whole thing, it's everything. So, oh, and along with that rate of change, it breaks down to this. It's going really fast. 3.69 changes an hour, 24 hours a day, 7 days a week. During the 2.5 to 2.6 development cycle, we were running about 2.5 changes an hour. And that was unheard of. Nobody ever thought we could do that. Since then, we've been going up. I don't know why. We're getting faster. We're getting faster, we're doing more rate of change, and it's getting bigger. So this is something that's stable. So here's a graph. If you want to see all the lines of code added, modified, deleted over time, I just did for the 2.6.11 and on. If you look previous to that, it was a little bit less. So it's kind of staying around the same, but lines added keep going up. It's interesting. It's not really trend-worthy, but it is continuously going up. What is trend-worthy is the changes per hour is continuing to go up. 2.6.25 changes per hour is amazing. Oh, and all that rate of change does not include moving files around. Moving files around the kernel doesn't affect it at all. It does not change that at all. So we're going faster, doing more rate of change per hour per release. Everybody happy? Nobody's questioning that? Oh, come on. All right. So how do we do this? Here's how we do this. Ostensibly, it starts off with the developer on the bottom. They make a change to a file, they find a bug, they want to add a new driver, do something. Then they take that change, that patch, and they send it off to the maintainer of the driver, or the file. In the kernel, we have about 600 unique maintainers that are listed on who owns what. If you can't find who owns what, you can look in the file using Git and see who modified it last. Whoever touched the floppy driver last is the maintainer. Never touched the floppy driver. So that person's responsible for looking at it. And then they see it, they review it, and then they sign off by it. They say, this looks good to me, I think it's okay. And they add their signature called signed off. And I'll talk a little bit more about that later. So the developer says it's signed off, it's good. They say it's good. They send it off onto the subsystem maintainer. Subsystem maintainer like USB, PCI, VFS, security, core, things like that. They consolidate all the patches from all the other people, and then they hold on to them. They create these little mini trees everywhere. These little mini trees are either in Git, using Quilt, I think that's all everybody uses, some tarballs maybe. Then all that, every night, gets pulled into the Linux Next tree. It's run by Stephen, Rothwell in Australia, works for IBM, Oz Labs. He pulls it in every night into the Linux Next tree, merges them all together, and sees if it builds or not. Sends you angry emails if you break the build, you break the merge. It's great, it's awesome. It's testing all the subsystem maintainer stuff for all our development things. Andrew, at the same time, is now relying on Linux Next and sucking everything into his tree about once a week or so. And then also, he pulls things from the Linux kernel mailing list, other mailing lists that happen to get dropped by subsystem maintainers and whatnot. He sucks those into his tree. And then he does a release every couple weeks. So that's testing. This is the developmental stuff. So all the crazy stuff the subsystems maintainers are holding on to, all the stuff that's coming across the mailing list that Andrew picks up, gets pulled into these releases. Then, when Linus says it's the merge tree window's open, I'll talk more about that later, all the subsystem maintainers hit Linus. You got 2 weeks to hit Linus with all the changes you want. So they all go to Linus. Andrew sends a bunch of stuff to Linus after the subsystem maintainers get there, and then we go on the cycle of releases. I'll talk more about releases later. So a nice little tree structure. So Linus and Andrew and the next tree. Does that make sense? A nice hierarchy, right? Nice and pretty. So I tried to graph this, looking at the relationship between people and the way patches flow through the tree, thinking it'd be a nice pyramid and whatnot. It turned out it isn't. I made a graph that was about 40 feet long and 4 feet tall of one kernel release. It was a mess. It's a big, giant spaghetti mess. It looks like an internet routing system, which is good, because it means that if this person doesn't pay attention, we route the packets around them. Andrew picks it up and then sends it to the subsystem maintainer, sends it to Linus, or this person sends directly to there and goes around the maintainer, or this person disappears for a week. So it's very good. It's lossy. We can handle people disappearing, handle people reappearing, and it works out really well. It isn't a strict hierarchical development system, which is good. And it shows how we can keep up this massive rate of change so fast. It's kind of scary. If you own a file or a driver, you need to accept the fact that other people are going to be changing it, ostensibly without you knowing it, but hopefully you should be paying attention. And you just have to accept that, because other people can do that. You can always change it back if you didn't like it. But that's the way we get things done. That's how we can work so fast. Make sense? Cool. So here's a release cycle. So Linus does a release based on something. We say it's good. So then we have 2 weeks. We can throw anything we want at Linus. All the subsystem maintainers throw everything we want. Ostensibly, it's been tested in the Linux Next tree. Before that, it had been tested in the MM tree from Andrew. So we hopefully expect that the code has been tested. It builds. It hopefully compiles sometimes. And it all merges. So that's when the hundreds of thousands of patches go in at once. 2 weeks. Linus releases an RC1 kernel. Then the subsystem maintainers that were on vacation or forgot about the merge window being open wake up and say, oh no, I forgot my stuff. They send it to Linus again. So then he does an RC2 a couple weeks later. Hopefully, that's getting better. People are slowing down. Everything happens between RC1 and RC2. Then it's bug fixes. We start doing bug fixes. We track bug fixes, regressions. We do RC1, 3, 4, 5, whatever, until we think things are slowing down good enough. And boom, Linus says, OK, this one's good, out the door. And then we start the whole cycle over again. There is no stable and unstable development trees anymore. We used to have odd was unstable and development, even was stable, not anymore. For the past 4 years, we've been doing this model. When we finally realized that this model really worked good, we said, oh, we should try and do a release every 2 to 3 months, right? If you look, we're releasing on an average of every 2 3/4 months for the past 3 to 4 years. Like clockwork, you can trust that a new kernel will come out between 2 and 3 months. This is a really, really good thing. It lets the upstream distros figure out in their schedules when things are going to be done. Within a reasonable time frame, they can plan when things are going to come out. Distros can figure that out. Developers can figure out, oh, I missed this merge window. When's the next one going to come around? They don't have to worry that their stuff's going to get dropped for forever. It works really, really well. One thing that happened, though, is we realized during this 2 to 3 month time, what happens about security bugs or people that actually use the kernel.org kernel? What happens then? There's bugs, security problems happen. What are we going to do? So we formed, 2 people formed the stable tree, which is me and Chris Wright, who works for Red Hat. And we do security updates, or bug fixes, .1, .2, .3, .4, .5. And we have a real strict list of rules of what we will accept, what we won't accept. It's pretty easy. Has to be bug fixes only, security fixes. The patches have to be in the upstream tree already, unless it's some really, really odd thing. Things like that. Must be small, obvious. We do those releases every couple weeks, whenever we get around to it. Sometimes we're slacking, sometimes we're not. Security updates, we can do it. Usually if we get it in the inbox, we can do it in a couple hours. So we release things as soon as possible if we can. And that's working out really, really good. The fun thing is, we drop them. After 2.6.20 comes out, we might do one more 2.6.19 stable, and then we stop. We don't have to do it. We don't have to maintain that for forever. You can maintain it for forever if you want to. Somebody picked up the 2.6.16 kernel, decided to maintain it on his own for a long, long time. We all thought he was crazy. He got a job out of it. So maybe he wasn't so crazy at all. So that he could do things over time. So it worked out really well. If anybody wants the 2.6.24 kernel to maintain for a while, let me know. I'll give it to them. We don't care. So that's how it works. Stable releases happen, development releases happen, and then we drop stable trees. So we don't have to maintain them for forever, which given our rate of change previously is a good thing to do. Make sense? Everybody happy with that? Is it working? All right.
So you guys don't have a notion now of sort of every so often a really preferred release?
We don't have a notion of a preferred release anymore. No, every release is a preferred one. The latest one. Based on our rate of change, if you report a bug problem in two kernels ago, given how fast kernels have been changing, we're going to ask you, can you reproduce this on the current version? It's the first thing we're going to ask you. So yeah, so everything's preferred. The last run was preferred. Now note, when the distros do releases, we know what kernels they're going to release. So sometimes those kernels hang around a little bit longer. Fedora and OpenSUSE are based on 2.6.25 right now. Odds are that kernel's going to hang around for a little while because Chris Wright works for Red Hat and I work for SUSE. So we'll probably want to hold on to that kernel for a little while longer, make sure bug fixes get in there and it's good. But if you want the new features, things like that, you should go to the latest one. No time. Yeah? Why a 2-week merge window and not what? Why not accept merges all the time? Because we want to be able to throw a bunch of things and we want to shake things out and stabilize them. We want you to test and feel good that, oh, we can. At the very end, we don't want to accept a massive bunch of USB changes that nobody's really tested or run for the past 3 weeks or so. You know, we want to at least look at some kind of software, good engineering practices. Look like it's something, we know what we're doing here. Yeah.
There's never a period where there's no merging. It's more like there's the merge window where you're accepting new work, and then the RC window is you're accepting bug fixes. Is that correct?
So there's no gaps where we're not accepting any merges. Yes. Well, we think of, yeah, when we use Git to send things to Linus. So he pulls from the subsystem maintainers trees and, quote, merges them in. So that's what we merge things. But it should be bug fixes only. From RC2 on, unless it's a really odd thing, we should have bug fixes only are going into the merges. I think of merging as new features. I'm sorry. It's the wrong terminology. You can use Git to send stuff to Linus. Linus came here and talked about Git. I use Quilt. Quilt's really good, too. So, yes. How do we test? Yeah. The fun thing about a kernel is there is no good way to test it except running it. You can't write unit tests. You can write unit tests that ostensibly test some of the external features, such as the system call interface hasn't broken some odd things. But what really is testing with the operating system is running it on your machine. There's so many hundreds of thousands of permutations of devices and interactions with timing and everything else that we want to run on all your machines. So we rely on you to test. We rely on the developers to test. And it's the only way we can obviously test. My classic example is I had a problem when you were plugging in 2 USB devices at once and yanking one out, the data was being streamed out to. You can't unit test that. unless I want to plug. I have a big box of USB devices that I do test a lot, but it doesn't make for an automated system. So we ask you to test it yourself. We rely on the development community to test. That's all we can do. There isn't a sane way to write a unit test for an operating system. It just doesn't work, because we're relying on so many external inputs. People keep trying, and that's great. And we want as many tests, we want as many functional tests as we can get. But like performance, and with performance tests also, people are starting to test them, but it's a really hard thing to do that way.
So there is no formal, let's say, between, like there was this 2625, the last one, RC7, they were waiting for someone to get something. So is this some formal procedure, or somebody just knew something was wrong, and what if somebody didn't touch that particular thing that was holding it up?
So what was holding it up, and what was the formal procedure? We do track regressions. So like people report a regression, hey, this worked on 2620 and 2621 RC whatever, it's broken. Regressions we track. So towards the end of the release cycle, we say, have we fixed all the regressions? Have we fixed all the bugs that have been reported? Some people are trying to track the bugs that have been reported. If it isn't a regression, and it just is a bug that's always been there, or it's something that new happens, or for something that's been added that's brand new support of hardware, we don't really treat that as important as a regression from actually machines working. We want to make sure we never break a machine that was working previously. We'll rip whole features out because we broke a machine that was working properly, which is tough. ACPI and some interactions, some low-level platform code is nasty. So we change that, and it breaks whole models of laptops. There's an IBM series of laptops that was notorious for breaking whenever we change anything in ACPI. It's tough. So we try and track those. And that's what's keeping us, oh, look, we know that there's this one class of bugs that a bunch of people are hitting. Let's try and fix that before we do get between RC7 and the final release. So we do keep track of that. So if you have a problem, let us know. So as a developer and as a user, if you want to help Linux out, test these RC releases. Test them and let us know if there's a problem. Do you have regressions or not? And they're good. I mean, all these are run on everybody's machines. You don't have to worry too much about these things. I wouldn't run it on something that's production-wise, but definitely run it on your local machines. I run it on my laptop, all the other ones. If you want to test want to help us test what's going to happen next, test the Linux Next tree, test Andrew Morton's tree. That shows that crazy developmental stuff that's still under heavy development that we're trying to merge in and figure out what is good enough to go into the next merge window. We have features in there that aren't really good enough to go. They might be a couple releases away. Things like that. That's a question. Cool. All right, move on. Like I said, we're doing this every 2 3/4 months. So we're actually doing what we said we were going to do. And that's a good thing. It's a time-based release cycle. It's turned out to be a really nice thing, works really well. A lot of open source projects are kind of switching towards it. It works, you know that, oh, if I miss this feature, this window, 2 3 months later it'll get in. It's a good thing to do. 9.2 million lines. We've been growing at a rate of 10% increase in code size per year since I started tracking it, about 260. It's a linear graph. It's just pretty much straight, which is amazing. We're still growing. We're still getting bigger. That's a pretty big chunk of code. Now, not all machines run all 9.2 million lines of code. That's a fun thing. You run the core and a few drivers around it, networking, things like that. So that's everything. That's all the different platforms, everything else. And the last year and a half, this is the number that I find the most impressive. We had 2,399 unique contributors to the kernel. And that's amazing. That's showing we're doing really, really well. Now, half of these contributors only contributed one patch. Half the half contributed 2, half the half contributed 3. A little exponential curve there. But the top of the curve is getting flatter. When we did the 2.5 to 2.6, the top 20 people did 80% of the work. Now the top 30 people do 30% of the work, just by quantity of patches. So we are flattening out, and we're spreading the load out a lot more evenly. I looked, it was 200 people, the top 200 people did 200 people did 8%. Something, I was looking at the top 200 people. They did a lot of work. It's spreading out a lot better. So that's good. And here's the background is that graph I did, that crazy graph. It's on kernel.org. You can try and load it in your browser. It's a good SVG test. It broke Kinko's machines, crashed Macintosh. I got somebody from HP to print it out. He had printers in his barn, big roller printers in his barn. He printed it out for me. Kinko's wouldn't. So that's our number of developers. That's good. And our number of individual developers per kernel release is going up also. Our number of companies that are actually sponsoring developers is also going up, which is a really good thing, showing more companies are getting involved as the spread of Linux gets bigger. So let's talk about people, quantity. We can track people by quantity. This is just quantity, not quality. I'm not going to talk about quality. So this is the number of changes that got into the kernel. Top 10 people for the past year and a half. Number 1, Arjen Bunk, does lots of janitorial patches. Alviro VFS, Thomas Gleixner, the i386 and x86 Arch maintainer, along with Ingo Molnar. David Miller, networking core. Bart, IDE. Paul Munt is SH. Ralph Beachley is MIPS maintainer. Ingo again. Patrick Maharty is NetFilter. And Taejun is libata, disk drive stuff. So 2 of the disk drive guys, top 10. That's quantity. That's the number of changes that they got in the kernel. Yeah, it's fun thing going. So, signed off by. Remember how I mentioned every person along the hierarchical tree signed off on it, actually reviewed it? Here's the top signed off. This shows who are the gatekeepers and who's doing what. Andrew is the top, Linus is next. Now, the funny thing is Andrew has more than Linus, yet everything goes through Linus. Linus doesn't sign off on patches he pulls from sub-maintainers using Git, because he isn't looking at them. He's trusting those maintainers to do their thing. So I make up a Git tree for Linus to pull from. He says, great, you pull from it, and he doesn't sign off on those. That's why his number is lower than Andrew's. So actually the real number of patches that got in is less than the sum of those two. It's kind of funny. So again, David Miller, networking. Jeff Garzik, network drivers. Ingo, architecture for Intel. Me, Thomas, Intel. Maro does video for Linux, little webcam stuff. He does that in his own spare time. Works for a telecom company in Brazil. Awesome stuff. Paul MacHarris is PowerPC. John Linville is wireless drivers. So you can kind of see what areas of the kernel is doing a lot of activity. So again, video for Linux is a very active area. Wireless is a very active area. Interesting things. Top some. So let's see who is funding these companies. So we can see the people. We see the number of changes they do it. So who's doing this work? So again, for the past year and a half, Red Hat, IBM, Novell, Intel, Oracle, consultants. These are individuals working for consultants, either being paid by other companies or working for consulting companies themselves. Academia, I'm very happy to see academia is actually going up. That number's going up. And Renesas, I think they're an SH chip maintainer, developer, which is really interesting. They just popped in the top 10. So anybody want to guess what's number 1 and 5? Come on. Canonical? I'll tell you where Canonical is later. I'll tell you where they are now. They're about 300th, I think. Canonical had 6 changes in the past 5 years. Canonical does not give back to the community. But that's what they do. Linux Foundation, no. Linux Foundation is not on the list anymore. Because they only have 1 developer, Linus. They do a lot of, I'm sorry, a lot of what? DocBook? Docs, yes they do, but that doesn't know that goes in the kernel. Anyway, oh, come on. SUSE is Novell. So Novell, SUSE, same together. HP, no. HP, no. All right, I'll just go. You guys. Amateurs, number 1. These are people working for themselves. We have asked them who they work for, and they say, I'm a hobbyist, I'm doing this on my own time. And then number 5 is unknown. They are either we have no idea who they're working for, or that they wish to remain unknown. Some people say, I'm not allowed to say who I work for, here's my patent. So we track these stuff. So between the sum of those two, that's almost 25, almost 1/4 of the number of changes that go into the kernel is being done by people that are not being sponsored to do it. Another thing about these unknown individuals, none of them, well, I think about 5 of them are contributing more than 10 patches. So there are lots and lots of people on the tail that we don't know who they're working for. So it's not they're not large contributors. Or you can look at the other way, 75% of the development that's done in the kernel is paid for, is sponsored. Because these companies care about what happens to Linux. If you want to see what's going to happen to the kernel, what's going to work for you, you need to influence it. Everybody asks, what's going to be coming in the kernel? What's next? It's whatever you make it to be, whatever you want it to be. Lots and lots of companies are relying on Linux. You guys rely on Linux. Lots of other companies. I've given this talk to a number of companies. Only 1 company I've ever given this talk to is actually on this list. And my thing to send, what? Google's not on here. Where's Google? Google's 13. If you don't count Andrew. So, without Andrew, you count Andrew. I count Andrew too. Andrew does great work. But, so I was trying to think of a metric. Do you do the mean of a company's developers, you know, you look at the massive body, or do you count the net quantity, but then smaller companies, a fewer developers, how do you rank them? I don't know how. I'm trying to figure out some fun stuff with statistics. Wife's in graduate school. She happens to be taking a statistics class right now, so she has lots of ideas I can use here. So yeah, without Andrew, you guys are 40th. You guys rely on Linux. This either means one of two things, that the way Linux is going and the kernel's going and working is just fine for you, and you like it, and you love it, and you're happy, which is great. Lots of people are that way. But the other thing is, do you trust these companies to develop the kernel in a way that matters to you? I would say no. You trust these guys? They don't know your business as well as you do. You only know the loads that you do as well as you do. So if it's going as well, then fine. I'm happy and I'm not going to complain about it. Yeah, Brian.
No, I mean, one thing that happened to us on the Android side of things is they removed support for iNotify out of sysfs, which we actually were depending on.
Yeah.
If we had been more active earlier on, somebody might, you know, and the check-in I think mentioned, oh, there's only one thing in the kernel that uses this and it's not important. You know,
Yeah.
maybe if we were in there, we might have been involved in the decision. It might have still been removed, but.
At least you should know. I mean, if there's things you care about, that's fine. And that's fine. If you care about, talk about this thing, that's great. A lot of companies I talk to say, well, company on ranking so-and-so is doing our work for us, which is great too. A lot of these companies, I know IBM, or Red Hat and Novell, we both do consulting for other companies and do work for them. But again, they're overworked companies and there's no reason why the individual company yourself can't get involved. We make it very easy to get involved in the kernel development process. Based on our number of people that are contributing, it's kind of working. So there's no excuse for you guys not to contribute. So that's my reasoning. So let's pick out some other fun things. So 27 people, I went and looked. 27 of you guys contributed to the code last time. And here you are. So Andrew, number 11, awesome, great, very happy. David, number 149th. See here? I told him I was coming. So he is a perfect example of what I'd like to say is a great person to have. He started off working at a university doing janitorial kernel work. He looked at the kernel, here's a fix I can do, started running it, did it. Got hired by you guys, I don't know what he does, and has contributed now to the core kernel, the to the, what does he do? stuff, out of memory stuff, core kernel guy. It's contributing pretty well, 67. That's in the top 8% of all kernel developers by quantity out there right now. Great job. Paul, what does Paul do? I looked at CPU scheduling. That's good. Ken does what? Huge TLB and other sort of stuff. Nice core kernel work. Really good. And then there's Matt. Matt here? Okay. Matt puts everybody else in this company to shame. Matt contributed spelling fixes to the kernel. Which is awesome, and I will not say, and I love him, and that's a really good thing to have. But Matt beat out all your other kernel guys. He's number 5 out of the whole company, contributing changes that fix spelling. So if you're a developer, you should feel a little ashamed about that. Yeah. I mean, I gladly take spelling changes. I hope they contribute to more in the future, but come on. All right, guys. And then I gave up looking at the rest of what you guys do.
How does 27 compare to other companies?
On quantity? On number of developers? It's pretty good. There's some companies with like 90 some, which is amazing. I looked at, but then there's smaller companies with like 5 developers that are very high on the list too. So it's like I can't look at pure quantity of unique contributors. I just can't figure out a number. Do I look at the mean of the contributing one? I look at the mean here, you're way down at 7, you know? I think you guys want me to do that. So Martin, where's Martin? Martin disappeared. So the joke is, when anybody ever goes to work for Google, they enter the black hole. Never to be seen from again. Martin used to actually contribute to the kernel. I know Martin, so I can make fun of him. Here's some more. 2 patches, 2 patches, 2 patches, then we start getting to 1. Al, that's cool. Let's see, Al works here. He used to contribute a lot. Used to. And there's the rest. There are some interesting, and that's great, and that's awesome. And I have nothing against that, but if you, I know you guys do a lot of development in-house and have your own custom setups and certain things like that, which is great and fine. But if you think you can keep your changes outside the main kernel tree and keep up with that rate of change, I think you're going to have a problem. It's really, really hard to do. Even with our good tools that handle merging, Git, things like that. I know this really doesn't show it. None of the Android stuff has landed. Hopefully this Android stuff will land.
No, there are 4 of those patches.
Okay, 4 of those patches already are Android.
We have a lot more in the pipe, hoping to get a lot
Hopefully, yeah, I've heard that before. But yes, I trust you guys. I trust you guys will get the stuff. But so,
You have to trust your subsystem.
trust our subsystem maintainers.
There's a lot of talk about how easy it is to contribute, and your mileage may vary sometimes.
Your mileage varies sometimes on how, yes, on how easy it is. If you ever have a problem with getting things in, talk to me, talk to Andrew, talk to the other people. We will help make this happen. I have developers that are willing to help out with cleaning stuff up. We take code from other companies that are not the proper coding style. We'll clean it up for you. We'll maintain it. We'll get in the kernel. We do this kind of stuff all the time. So it shouldn't be anything like that. So my main point here, you guys rely on Linux. There's no reason why you guys can't get involved. You guys should contribute, help drive it in a way that you feel is going to work best for you. Otherwise, it's going to work good, and I hope it still works. So everybody asks what's new. Here's some of the things that happened in 2.6.26. It's a joke to tell you everything that happened new. It's a lot of stuff happened. A lot of stuff. So, any questions? That was fast. In the back, yeah.
When you talk about the growth of number of lines of code in Linux, I think that probably like 95% of that is device drivers?
The talk of the code, 95% of it is drivers. No, I think you missed in the beginning. 50% of the code in the kernel is in drivers. 55% of the code in the kernel is drivers. The rate of change is exactly proportional to the amount of code is in the kernel. So those 4,000 some lines added, 55% of that is in the driver subsystem. So 5% of that is in the core kernel. It's proportional across the way. So the majority is drivers by a small bit. After drivers is architecture-specific stuff, then networking. But that's it. So it isn't all drivers, which is scary in a way. That means your core of the kernel is changing that fast. Your core of the kernel is changing at a rate that blows all other operating systems away just by looking at the map that's just touching the core of the whole subsystem. Think about that, Solaris. Yeah.
So what would you say is driving the change to the core kernel? Is it because people just keep picking up better ways of doing things, or is it because the requirements are constantly changing?
So what's driving the change, the thing in the core? What's driving the rate of change in the core? It is the fact that Linux is. I mean, Linus always jokes Linux is not intelligent design; it's evolution. Which means we react to stimuli that's happening in the world. It's like, oh no, we have to support this new architecture, which means we have to change the core to do this now. We don't overplan things. We take what's happening right now. So yes, new features happen, and we add, and we figure out how to change the core to get them to work. People come up with, hey, here, I have a good idea that we can get this, if we rewrite the locks to be mutexes instead of spin locks, we can get the RT stuff in there and get real time in the core. The real-time stuff shows that you can take these crazy out-of-the-tree patches and merge them into the core kernel, and now we have a real-time aware kernel of Linux, something that people said that could never be done, which is pretty amazing when it's done. So it's everything. It's just responding to external stimuli. So we're not over-planning, we're reacting at the time that it needs to be done, which sometimes means we're a lag a little bit. So some hardware companies will come out with a new device, and we're like, oh crap, we need to rewrite this. Luckily, we're getting better, and these hardware companies are getting involved in the process. Look at Intel on that list. Intel's very high. They're very big on Linux because Linux runs on all their chips. They want to sell chips. They make sure it works really good on their chips. So, oh, no. Obligatory. Come on. Obligatory penguin picture. Yeah.
So why don't you guys don't pay more attention to consistency?
Why don't we pay more attention to consistency?
I mean, interfaces, or let's say when they put the command line, let's say moving from subversion to subversion, let's say I just did this a few days ago, MTD file system, it has to be specified differently in the command line to mount it. So, I mean, couldn't be, and this has to be, somebody has to go into the code and find this out. It's not really documented anywhere.
some things don't change rapidly, and our interfaces do change rapidly. Hopefully, we never change the user space interface. Talk about the boot line changing for the MTD stuff. I don't know. Maybe they had a really good reason to do that. Hopefully they did, and that sounds like a foolish thing to do. We hopefully never changed. We change the internal kernel API all the time. Everybody's like, oh, you have to have a frozen, you have to have a stable API. Then you say, what API? We have 9,000 symbols. We have 12,000 different structures, that are passed around inside the kernel. You can't freeze that because it doesn't let you ever change anything. So inside the kernel, we change all the time. We change rapidly. We have really good reasons for doing that. But outside the kernel, user space APIs, we should never change. I can run binaries that were built for 0.696 just fine today on the kernel, 2.6 kernel today. Syscall interfaces don't change. For the most part, there's a little gray area of some interfaces that around the kernel and user space, like the proc file system, that end up changing every once in a while, but hopefully we catch all the users around that. But we're trying to document that. We're documenting that user space API now. There's documentation ABI that we document that. The command line stuff we do document now. That it changed was odd. I don't know why. It shouldn't have. You should complain to the developers. Maybe they didn't realize they broke it. Sometimes it's that. Like, oh, I didn't realize I broke that. That's a bug. I need to go fix that. Regressions are always going to happen. And hopefully we fix those. In the back.
Once upon a time, you advocated that distributions ought to always just update the most recent kernel release.
Yes.
For their enterprise distributions on the ground that the stable user space API meant that should be a forever forward progress.
Yes.
At the same time, LWN reports on a regular basis that Andrew Morton says the quality of the kernel and regression are not going in a way that makes that useful.
Yes.
Do you still stand that way now? Is that how you recommend distros do that?
So the question is, a while ago I said that enterprise kernels should just rev the kernel all the time for their enterprise kernels, while Andrew keeps complaining that the user space, that our quality going down in our reporting. I think Andrew's wrong. I see every single kernel bug that comes in to 3 different distros, or to kernel.org and to 2 distros, Gentoo and SUSE. And over time, that number reported is flat. Red Hat's bugs, their bugs reported for the kernel, has actually gone down. Now, either that means we have a fixed number of testers and people reporting problems, which could be true, but we're increasing our size of our code, and we're increasing the number of users of our code. So ostensibly, I'd like to think that we are doing better because our code size is going and our number of bugs reported is flat. Andrew sees a lot of bug reports. He sees a lot of stuff and a lot of stuff all the time. I see a lot of stuff all the time too, but if you look at our rate of change for what's happening, I would argue that we are doing better. We're doing good. If we break a user space API, let us know and we'll fix it. Regressions always happen. I can't say that. So as far as the enterprise version, I said it before publicly, I still think the enterprise kernel model is wrong. I get paid by an enterprise kernel company. I think it's wrong, because if you look at what they do, so take SUSE, or their SLED 10, SUSE Enterprise 10. They took a 2.6.16 kernel, froze it in time, and said, okay, here's what we're going to do. And they fix some bugs and make sure it passes all the regression tests and ship it. A year later, companies come along and they say, we're going to do a service pack update because we need to support new hardware. Problem is, new hardware comes out that changes the guts of the kernel based on the fact that we didn't know those things were going to happen. We didn't know libATA was going to happen. We didn't know these new devices were going to happen. We didn't know the wireless stack, what was going to happen there. So you go back and you kind of shoehorn all this stuff into there. If you look at what we have, I think, 3,000, maybe 4,000 patches to 2.6.16. It's not a 2.6.16 kernel anymore. It's 2.6.16 with a bunch of bug fixes that we know were reported to it. And that's scary, because we know a lot of bugs have been fixed between 2.6.16 and what we have today, 2.6.25, that weren't reported, that weren't fixed, or that we didn't know about it, and we didn't backport. So ostensibly, the kernel user interface should be stable and stay the same. We don't change that version number to make people feel good. They're used to the old Unix model, things moving very slowly. The Windows model, things move very slowly. They think, oh, they have a stable API. No, they just have a slow API. All those kernels, all the other operating systems, they change. They break their API. They break their driver API. I'm on the Windows driver development mailing list. It's the best mailing list ever. You just see the quotes from the Microsoft developers. Oh yeah, we did, something changed there, so we don't remember what change you're going to have to test. A lot of angry developers all the time. So just like users, just like Linux, we change our APIs all the time. They don't have a fixed API. So for inside the kernel, outside the kernel they do, hopefully. Outside of our kernel, we do. So I still think that you should move forward. Now, there's a model of people that take a box, an enterprise box, put it on it, and throw it in the corner and don't touch it for 5 years. And that enterprise model that only gets security fixes and backports to that, that's great. But that's only about 20% of the market out there. Because if you buy a box and shove it in the corner, and you're like a year from now, and you want to buy a new box, well, the new box is new hardware. And you have to support that new hardware on that old version of kernel, and that doesn't work. For a desktop, it just doesn't work. So I still think the model is you got to move faster. So inside, I'm trying to argue that. Red Hat's trying to argue that. See what works. You know, it's an interesting dilemma. Somehow we're still making money, so I'm happy. That's it. You guys are easy.
So where are you going to go next? What's big?
What are we next? Well, what's next? Yeah, well, like I say, it's whatever you want it to be. Things that I think are cool, KVM. KVM is really, really cool. It's running a virtual machine. It's a hypervisor, turns Linux into a hypervisor. I think it's going to win out over the Zen model. It's a different model, or the VMware model. If you look at what VMware does, that's really Linux running there. So all the big embedded or big hypervisor guys are really running Linux. It's kind of funny to watch. But so KVM is cool. KVM is now ported to S390 mainframes, ported to IA64, ported to, I think ARM's coming, and there was some other architecture that got ported to. So KVM is really cool. That's a really neat technology. Lets you run virtual machines. So there's another way. If you have an enterprise distro that you want to run fixed, you can run it on top of KVM or a virtualized machine. You change the hardware. You get your new drivers for your virtualized machine, for your low-level stuff. Then your virtualized machine, you can still run your old version of Windows just fine because that API between the two is fixed. And that's a neat idea. So you can run your applications that are running your old things that are running on those old APIs, especially your C++ libraries. Enterprise distros have a certain C++ library. You never want to change that, things like that. I know some big shops, Linux shops, they're stuck using Red Hat Enterprise 3 because the C++ developers do not want to ever change the compiler. So what those guys do is they strip out the kernel underneath and replace the kernel with the latest enterprise, or the latest kernel.org kernel, and then the users above that never even notice it happens. They use Zen, they use a lot of raw metal stuff. So I like KVM. KVM's cool. USB 3 is coming, hopefully sometime in the future. I'm involved with that. That should be good. Fast devices. Yeah?
Yeah, that's what, so I was wondering, you basically mentioned how the rate of growth is growing really fast, and you mentioned how the whole system is lossless and very dynamic. I was kind of curious, do you know, like, the load on the particular subsystem maintainers, has that been increasing, like, on a particular individual? And what's your plan if people start to get tired?
So is the load as we... Yes, what happens if Linus wants to settle down? Linus is pretty settled down. Settle more. The subsystem maintainers, what's our load, and as our rate of change? Yeah, our load has gone up. I know my personal load, I don't maintain the PCI maintainership anymore because I wasn't paying good enough attention to it. I know somebody that is going to give it better attention is now taking over. So hopefully we are smart enough to recognize among ourselves that when things are going wrong and we can change. We are nothing but introspective and love talking about this. Every kernel summit, we always talk about the process. On the mailing list, we argue about the process. Is our process good or not? And we change things all the time. We add the stable tree because people are like, hey, our process really isn't covering that. Let's see how that works. The Linux Next stuff. Hey, this process isn't working. The subsystem maintainers are burning out. Let's try this. So we are nothing if not keep trying things. So hopefully we just keep trying things, and it seems to be working really, really well. Well better than we ever thought it would be. We haven't hit any max limits yet so far. Every time we do a kernel release, like, this is the fastest ever. The 2.625 kernel blows away all those are average numbers. 2.625 is the fastest, most amazing rate of change, most developers, most individual companies, than anything we've ever done. It's crazy. And now probably the next one will be more, faster. So, I don't know. Hopefully, I don't know where we're going to stop. We've already broken all the records, so I don't know. We're making it up as we go. Don't you feel good about Linux now? Yeah, Chris.
So I have a sort of strange question. I mean, the SATA layer is kind of sucky right now. How's it going with that?
SATA layer is sucky? That's news.
They use a lot of CPU, more than it should.
They use more CPU? Then let the developers know.
Okay.
I mean, that's news to me, so let them know. If they don't know these problems, then that's a big thing. If you find a problem, let us know. That's the best thing about our development model. You can find the person responsible for the code and make fun of them. Or give me a patch. Well, that's signed off by everything. So that's we like to call it the path of blame. So you see a bug. Hey, look, all you guys missed this. Fix it. So yeah, if it's using too much CPU, let us know. We'll work on that. Taejun's really good, really responsive. Jeff Garczyk's really good at that. So they're good at this stuff. A lot of this stuff is really weird hardware. Some of the hardware is written so that it's requiring more CPU power to do some of these things. Just because some of those manufacturers are also CPU manufacturers. So you want you to buy new CPUs. I don't know. One thing about KVM, it does make you buy new CPUs. That's why AMD and Intel really like it. So get the virtualization
Does
stuff.
KVM lock the whole kernel to a hypervisor range?
KVM is the KVM makes Linux be the hypervisor.
Okay.
The way as a kernel developer, it is the hypervisor. If you look at the way Zen model is, they have to have their own scheduling, their own memory management, their own power management. So, and then they have Linux running on the side to handle the drivers, because nobody wants to write drivers. Linux is always used for drivers. Herd uses Linux for drivers. Yeah, take that. So why not? So Zen is having to duplicate all the NUMA stuff, all the power management. Never run Zen on a laptop; it'll suck your power dry. So why not just use Linux as the core? Because the core of Linux is equal to the size of the core of Zen. Actually, Linux kernel is actually developed by more people. Maybe they know more things. They can do more things faster. So the KVM model is we use Linux, and then the instance of the guest operating system runs in. There's a little driver. There's a KVM driver, and just runs up there it runs as a process. So the really cool thing about that is real time. You can now real time schedule these guest operating systems. And the real time is a really neat thing. Some people can measure network latency and latency of processes in dollars. And they can do that in dollars. And then, so if they can reduce that, they can make it predictable. They can throw some really, really big machines at it and make their costs go down and make more money. So real time really matters for those guys. Real time might matter for you guys for network latency. Other big companies that do a lot of web services really care about the network latency. They want to be able to schedule it. They don't want to be waiting for another process to come in and finish that thing. They want to be able to know what's going to happen deterministically. So anyway, so KVM can handle that. KVM can then real time schedule your guest operating systems. Zen can't do that. Zen also did their development off in the side in the corner and never played nice with the kernel developers. They're trying to catch up now. I don't know if they're ever going to catch up, which is sad. They were there for it. That's it. You guys are easy. Cool.
Will there ever be a 2.7 kernel?
Will there ever be a 2.7 kernel? We said a long time ago, oh, if we ever do 4-level page tables, or if we ever replace a timer subsystem, maybe we'll need a development branch over here to do this. We've done those things. The really cool thing about that development model, and the one problem about the development model is we burn engineers' time. We waste engineers. We make you break your changes up into tiny, discrete units that can be tested and obviously reviewed. So we make you take your, I'm going to rewrite the timer subsystem into a lot of individual steps over time so that you never know things go in. So we've done these major things that we thought were going to have to happen already, and people didn't notice. Well, some of the performance guys noticed 4-level page tables went in. It killed performance some places, but they fixed that since then. So I don't know. We don't need a 2.7. I mean, the number's marketing, So I don't think so. Anyway, I think we're running out of time.
I just want to, let me go to the mic here. Is this mic active? Good. I just want to remind all of you that our outgoing open source patch process is very, very low ceremony. If you had a patch right now, you could ship it out within the hour. So we're not holding you back as a company. So
Spelling fixes.
Consider a spelling fix. Anyone in this crowd can do a spelling fix. So I'll encourage you to make Linux the best spelled operating system in the world. So. But yeah, no, we're absurdly fast when it comes to shipping out patches. We only ask that you look at your first couple, and that's mostly to make sure that you're not insane, and not from a technology standpoint, but actually from a craziness standpoint. So, and after that, we ended up trusting you, and that's how it works. So, please do it.
Great. Well, thank you all for having me talk.
Not that I think that 13 is bad. I think it's pretty good for a company of our type.
It is.
So it's a decent place to start.
It's okay. Good,
but it'd be great if we were 9.
Yes.
I'd like to make that first slide.
Yes, everybody wants to be on that first slide. Great. Well, thank you very much.